Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video we'll discuss about question number 31 of NEET physics paper 2016. Let us start question number 31. Given the value of Rydberg constant, which is 10 to the power 7 meter inverse, the wave number of the last line of Balmer series in hydrogen spectrum will be. In hydrogen spectrum, the value of for hydrogen atom, for H atom, the value of Z is 1. The formula for the series is obtained like this: 1 over lambda equals to R Z square, where R is the Rydberg constant and Z is the atomic number, into 1 over N1 square minus 1 over N2 square, where N1 and N2 are the orbits. Is transition from, this is your N2 suppose and this is your N1. If the transition is occurring from N2 to N1, then we write like this. This is the orbit, this is the orbital number, and this is the another orbit number to which the transition is taking place. The electron is in fact jumping from the N2 orbit to N1 orbit. Thereby it emits radiation of energy equal to h mu, the difference of the energy of the two levels. Now, in case of a Balmer series, we know that in a hydrogen spectrum, the first line is Lyman, the next one is Balmer, third one is Paschen, and so on. Now, the situation here is that the last one is infinity. Here n is 1 here, this is n is 2, 3 and so on. This is n equals to infinity. This is the last line from where it can jump to any orbits. Now, if any transition is taking place for any orbit to first orbit, like 2 to 1, 3 to 1 or infinity to 1, the series of wavelengths that we get is called Lyman series. Similarly, if any jump is occurring or any transition is occurring from third to 2 or fourth to 2 or any other orbit to second orbit, the series of wavelength corresponding to the energy difference that is released, and the series is called Balmer series. Now, the question is, in the Balmer series, the last line wavelength number is how much? The last line means the transition will be from infinity to 2. So when the transition is infinity to 2, so this is infinity and the transition is to the 2. So therefore n2 equals to infinity and n1 is my 2, because the transition is occurring between these two states. This is the infinite level and this is the second level. And if I substitute the values and what is the wave number is the reciprocal of wavelength. So therefore the wave number equals to Rz square 1 over N1 square minus 1 over N2 square. The wave number for Balmer series, R value is 10 to the power 7 given in the question. Z is 1 for hydrogen atom, so it is 1 square. Transition is from infinity to 2, so n2 is infinity and n1 is 2, so it is 2 square minus 1 over infinity square. This becomes 0 and this is 1 by 4, so it is 10 to the power 7 divided by 4, which is 0.25 into 10 to the power 4, 10 to the power 7. This is 1 by 4 is 0.25 and to 10 to the power 7. This is the wave number we are getting here, and that is in meter inverse. So therefore, if I see the option, then it is 0.25 10⁻⁷. The option number 4 is the correct answer to this question. Okay, thank you.